Hi, everyone. Welcome today, and thank you for joining us. We are excited to talk with you about how cloud technologies impact your control environment. Just for time purposes, we'll get started right away to keep on track. So we have a large group registered for today's presentation, which for us kind of confirm that while the topic of cloud technologies is not new, it remains highly relevant as companies are adopting these solutions. Participants on the webinar today come from a few different perspectives. We have folks from IT and information security, finance and accounting, as well as internal audit. I'm pretty confident that everyone will gain some valuable takeaways from today's presentation. My name is Cara Britt, a director in Cross Country's Risk and Compliance Practice, and I will be getting us started on today's webinar. But before moving into the presentation, I wanted to review a few administrative items. First, all attendees are participating in listen-only mode, which means you are muted. This webinar is CPE eligible. In order to receive CPE credit, you must attend at least 50 minutes of the webinar and answer 3 of the 4 polling questions. If you have a question during the presentation, please use the Ask a Question box in your media player in the lower right-hand portion of your screen. Your questions will be in private and will be responded to toward the end of the presentation. And then finally, at the end of the presentation, a short survey will pop up, and we would appreciate any feedback you have on our webinar today. So here are our presenters. For myself, I've spent my 20-year career in internal audit and risk management, and much of this has been from the chief audit executive role. My involvement with cloud risk management has been from this viewpoint, ensuring that our audit strategies continue to evolve and address cloud-related risks. And kind of during this process, when I talk to people, oftentimes I find them kind of thinking that cloud risk management is synonymous with vendor risk management. But the reality is that there are several other aspects that should be considered when understanding the impact of cloud solutions on the control environment. And that's what we're going to cover today. So with us, we have Christine Russell, an associate director with significant experience in governance, risk, and compliance focused on the IT environment. We also have Chris Burrell, an experienced manager with expertise in cloud cybersecurity architecture and strategy, threat modeling, and cloud operating model design. And with that, we'll dive right into the presentation, and I will hand it over to Christine.
Thank you, Cara. Hello, everyone. Today's key learning objectives will cover cloud computing basics, just to level set on some of the terminology. Then we will talk about how the cloud impacts your control environment, key elements of cloud governance, and lastly, look at some useful cloud risk tools and frameworks. Let's start our cloud discussion today by talking about what the cloud is. NIST, or the National Institute of Standards and Technology, has a definition of cloud computing that is widely used. It identifies 5 characteristics. The first characteristic of cloud is that its capabilities are available over a network. A second characteristic is that it is available on demand and has a self-service aspect to it where a single individual can, on their own, provision cloud computing capabilities quickly through an intuitive user interface without human interaction with a service provider. The next aspect is that it is scalable or elastic. This is where computing power or capacity can automatically increase or decrease to meet current needs. The fourth is resource pooling. There are different ways to pool resources. For example, in one scenario, customers might share a single software instance that serves one or more other customers. Customers are logically separated by means of system configuration to maintain their privacy and security. This can be compared with an apartment building where people share the same building but still have their own apartments and privacy within that infrastructure. Or customers may only share a data center where they have their own dedicated hardware and software, but everyone's dedicated hardware and software are under one roof, meeting the criteria of pooled resources. The last characteristic is measured service. Cloud usage can be metered based on some factor, which could be storage or processing in a pay-for-what-you-use cost model. There are 3 cloud service delivery models. Each service delivery model has a different split of responsibilities between the cloud service provider and its customer or your organization. The darker blue color represents items managed in-house, while the orange represents items managed by the cloud service provider. The first column characterizes a traditional on-premise IT structure where everything is housed and maintained on an organization's premise by a staff of IT personnel that is a part of your organizational structure. The next box is infrastructure as a service, which is a third-party hosted IT infrastructure without applications. It provides and maintains the hardware, storage, and networking that allows an organization to build its own IT environment. In theory, this cloud model puts the most responsibility and control back into the hands of the organization as opposed to the cloud provider. Examples of infrastructure as a service include AWS or Amazon Web Services, Microsoft Azure, Google Cloud, and Rackspace. Next, platform as a service is where organizations can build their own application solutions and still maintain responsibility and control over application processing and data, but shifts responsibility to a third party for the other system layers. Similar examples include AWS, Microsoft Azure, and Google Cloud. Software as a service is the most commonly understood form of cloud service. It provides an application used by end users. This model shifts the most responsibility, including application processing data and most control performance, to a third-party provider. Often in this model, items that still might be managed in-house typically includes user access administration, where a dedicated team within your own organization are still assigned to granting, removing, and periodically monitoring users' access to the SaaS application. Some fairly common examples include Workday, Gmail, Dropbox, Salesforce, etc. There are 4 cloud deployment models. In a private cloud, resources are used exclusively by an organization, a single organization within a private network, an ideal model for organizations needing more control over security, data, and systems. A public cloud consists of multiple tenants sharing cloud processing power simultaneously. This model can be used when security and compliance requirements are less of a risk. A hybrid cloud allows applications and data to flow between public and private clouds. A hybrid cloud might be ideal for those working with big data. For instance, a company may keep its transaction processing power in a private cloud, but run analytical queries on that data in the public cloud. The less talked about deployment model is the community cloud. This is a cloud environment built and operated specifically for a targeted group that consists of several organizations with a shared interest and with common concerns, such as the need for certain levels of security and compliance requirements. Government agencies, universities, and central banks often find a community cloud useful. For example, a community cloud can be used across several shared federal agencies where the privacy and security of a private cloud is desired, but the cost is shared amongst a few tenants. Let's go to our first polling question. What cloud delivery model or models is your organization using? A, infrastructure as a service, B, platform as a service, C, software as a service, D, some of the above, or E, none of the above.
Hi everyone, just as a reminder, you must answer 3 of the four polling questions in order to receive CPE credits. We will now give you 1 minute to answer this question. "20 more seconds before we close this polling question. We will now be closing this polling question.
Thanks, Katie. Well, it looks like the majority of you answered some of the above, which I think is pretty consistent with what I've seen as well. Many organizations have created a technological landscape of multi-cloud and on-premise systems to best meet their business strategies. Cloud spending is not slowing down. In fact, it is increasing every year across various industries and companies of all sizes. To help demonstrate this, here are some growth projections for cloud adoption and usage, as well as some statistics on key concerns for going to the cloud, which largely pertain to security and keeping data protected. The growth can be attributed to the reasonableness of cloud pricing, which has come down in recent years. The cloud has democratized computing consumption, helping to facilitate organizational strategies to quickly attain desired technology, such as technology for data analytics, artificial intelligence, automation, and so on. Since this webinar is about how cloud technologies impact your control environment, let's take a moment to talk through some examples of risks in recent news headlines. From the previous slide, we know that one of the biggest concerns about going to the cloud was data protection or security. We've all heard numerous stories of data leakages via human error or persistent hackers. In fact, Uber experienced a breach in 2016 when hackers obtained AWS credentials that were stored in a private repository called GitHub in plain text. Because Uber was not using multi-factor authentication for this repository, hackers were able to crack the password. Multi-factor authentication is the use of two or more pieces of information to validate user authenticity, such as password or PIN, plus a phone authentication code or token. Hackers were able to access a vast amount of personal data from drivers and customers across the globe, but instead of reporting the breach, the company gave in to hackers' demands, paying them $100,000 to delete the data and keep the incident quiet for a bit more than a year, violating breach disclosure laws. 2 years later, Uber was ordered to pay over $148 million to settle claims. Another recent headline pertains to cryptojacking, which is the unauthorized use of someone else's computing power to mine cryptocurrency that involves running complex mathematical problems on the victim's computers. Crypto mining continuously generates money for the hackers as they earn cryptocurrency for mining. Very recently, Tesla's AWS environment was exploited to mine cryptocurrency due to a security weakness. Public cloud platforms are popular targets for cryptojackers because they offer a huge amount of processing power in an environment where attackers can often mine under the radar, since processing and electricity use is already expected to be high. Last year, the Cyber Threat Alliance reported a massive 459% increase in the rate of cryptojacking. The process of mining isn't necessarily harmful, but it does consume extra electricity and processing resources that could potentially cause performance issues. Next, let's talk about availability. For 14 hours on November 19th of last year, Microsoft's Azure Active Directory multi-factor authentication services were down for many of its customers. A week later, it was down for a second time. As a result, customers were unable to log into Azure resources and some Microsoft SaaS products. Microsoft explained that the root cause is due to a programmed code change which provokes failures. When everything is working smoothly, it can be easy for an organization to judge a backup plan or a business continuity plan as an unnecessary effort, but the potential disruption could come at a much greater price. And we are up to our second polling question. Has your organization had a security incident involving a cloud service? A, yes, B, no, or C, do not know.
Hi everyone, as a reminder, you must answer 3 of the 4 polling questions in order to receive CPE credits. We will give you 1 minute to answer this question. We will now be closing the polling question and sharing the results.
It looks like the majority of respondents answered that they do not know, which is quite likely possible. Often these breaches are really kept secret. But according to a 2019 Thales Data Threat Report, 64% of those with digitally transformative technologies like the cloud, who spend more than 10% of their IT budget on security, say they have experienced at least one breach. So let's get into some of the key components of a cloud governance framework. There are common challenges that organizations face, whether going to the cloud for the first time or haven't been in the cloud for some time. To get the benefit out of cloud while staying risk adverse, you need more than just a set of controls. Start with a cloud governance framework that defines management's desired practices, policies, and controls, and provides a structure for aligning technology with business or organizational strategy. Over the next few slides, we will dive into the key components of a cloud governance framework. If you're wondering where to start on your cloud governance journey, begin by identifying an executive sponsor and establishing a cross-functional team to plan, design, implement, manage, and then continuously monitor and enhance the cloud governance framework. Secondly, define critical success factors to measure the team's success and to continually fine-tune the framework and strategy needed to drive cloud governance effectiveness. So let's talk about cloud policies and procedures. Establish cloud policies and procedures to set the tone and provide guidelines for going to the cloud and managing the cloud. First and foremost, there should be a policy regarding cloud adoption and procurement. This could also dictate who must be involved in making the decision to go to the cloud, such as the CFO, the CIO, legal, and other cross-functional team members, such as finance, human resources, marketing, operations, governance functions, and so on. Legal is a key player, as they will review contracts and help ensure the right terms and clauses are in place suitable for your organization. Overall, all of these policies will help provide governance and direction around data security, data retention, management of the cloud service provider, desired availability, etc. It will also help to head off the threat of shadow IT, which is the bypassing of IT as well as company policies or strategies to go to the cloud on their own, thanks to the ease of signing up. The biggest risk of shadow IT is that cloud services are procured that can't interface with existing systems, are maybe duplicative, or don't meet IT or business policies around security, encryption, or desired business functionality. Next, let's talk about cloud strategy. When establishing your cloud strategy, here are some questions to ask as you think through how your organization's objectives will drive your overall IT strategy, including the cloud strategy. IT cannot build a strategy by itself in a silo. Only through close collaboration between IT and the business units can a strategy be created for a cloud portfolio that will meet the needs of all stakeholders. In other words, is a cloud strategy aligned with IT objectives, and are those objectives aligned with the overall company goals and strategies? Consider also if management has even evaluated whether your organization is ready for cloud migration. Our next topic in the cloud governance framework is around risk assessment. Perform a cloud risk assessment to further understand what the cloud means to your organization. Even if you are already in the cloud, a risk assessment should still be carried out. In fact, performance of a risk assessment on a periodic basis, such as annually, is most likely appropriate, as factors change over time, whether external, vendor-related, or even related to your organization. Consider the risks listed here as you start your assessment. For example, financial reporting risks may be present if someone else is hosting your accounting or leasing software. How do you ensure the transactions are accurately and completely processed and that the data has integrity? Or take security. If not set up properly, can lead to data leakage if your cloud service provider is breached. Usually the cloud user and not the cloud service provider takes a reputational hit and is overall accountable and responsible for cleanup. In regards to regulatory compliance risks like SOX or HIPAA or other privacy laws, if they are missed, perhaps this might result in a loss of revenue, a loss of customers, a hit to your reputation, incurrence of regulatory penalties, and so on. But before we dive into the next section on internal controls, I wanted to talk about SOC reports, which are reports on internal controls at an organization providing a service. These are also referred to as SSAE 18s. Ideally, a SOC report will help you assess risk and controls at a cloud vendor prior to signing the contract and then during your relationship with the vendor. Most cloud vendors offer a SOC report due to customer demand. Essentially, a customer is unlikely to go to a cloud service provider without one. A SOC 1 report focuses on internal control over financial reporting. A SaaS cloud vendor should provide one of these to its customers if they are hosting software used for financial reporting or lease accounting or payroll and so on. Infrastructure and platform service providers like AWS or Google Cloud also provide a SOC 1, since many of the aforementioned types of software are built on their structures. Users of a SOC 1 would likely be accountants responsible for financial reporting, as well as your external auditors or your internal auditors. A SOC 2 focuses on non-financial controls and covers one or more of the 5 AICPA or American Institute of Certified Public Accountants trust services criteria. Users of this report are a little more diverse and are loosely just cloud customers, any cloud customer and business partner that interact with the system. Both the SOC 1 and SOC 2 report can be performed as either a type 1 or a type 2. A type 1 assesses the design of controls at a point in time. However, it does not test the controls to make sure they are operating effectively. A type 2 report requires the auditor to test the controls over a certain period of time, such as 6 months to a year. Type 2s are much more useful, and if a cloud vendor only has a type 1 report, it could be a red flag that maybe their controls are not operating as designed. A SOC 3 is a public-facing version of a SOC 2 in favor of a simpler report for marketing purposes. And a SOC for cybersecurity introduced in 2017 is very similar to a SOC 2 as well, but a key difference is that it does not have to follow one or more of those 5 trust criteria set forth by the AICPA. They can perform an assessment based on a different type of commonly accepted framework like the NIST cybersecurity framework. Many cloud service providers might have a need to provide one or more of these types of SOC reports to its customer base. Let's talk about some common SOC pitfalls. Hopefully the first point has been cleared up from the previous slide. And regarding the next 2 points, make sure the SOC report is useful to you. Does it cover the controls relevant to you during an acceptable time frame? The fourth point is regarding SOC opinions, and they're basically 4. If the opinion is deemed unqualified, this is good. It means there were little to no control exceptions identified. But please know it is not uncommon for an unqualified report to have a few minor exceptions that you should review and see how it impacts your organization. The next opinion is qualified. And an opinion can be qualified if controls are mostly operating effectively except for a certain area. In this case, review management's response to exceptions identified. Was an analysis performed to determine the impact of it? Has a deficiency causing the qualification been remediated? If not, is there anything you should do on your side to further mitigate the failure? Please note that reliance can still be placed on the other objectives that were not part of the qualification. The remaining 2 types of opinions, adverse and disclaimer, are red flags. An adverse opinion means the control environment is weak, as there were either too many exceptions or an exception with such an adverse impact on the control environment. Disclaimer means that no opinion was issued, often because the auditors did not have enough access to information to complete their work. Second to the last are the complementary user entity controls. These are controls performed by yourselves or the organization receiving the cloud service provider's service. A common example of this might be regarding access management, where a cloud customer is still responsible for periodic user access reviews, approving new users, and removing users that no longer require access. The last bullet point here is regarding who is going to be reviewing your SOC report. It's important to understand the contents of the report to best evaluate the risk to your organization. So ask for help if needed in reviewing a SOC report. We sometimes see that SOC report users are in a vendor management or procurement area and may not fully know the control environment that the cloud solution is being used for. So don't be afraid to raise your hand and ask for help. At this point, I will turn it over to Chris, who will talk about internal controls within the cloud environment.
Thanks very much, Christine. One of the core operational components of a cloud governance framework is the management of your internal controls. As we'll see in the next few slides, the control objectives are largely the same as your traditional IT environment, but how you achieve those objectives and measure yourself against them is going to be radically different depending on the provider and the service and how you're using that service. Cloud also gives the opportunities to introduce new controls that weren't possible or feasible in your old environment, and we'll talk a little bit about how you can use those to great effect in your audit. Just because a cloud provider provides a service to you, it doesn't mean that your organization isn't responsible for configuring the appropriate settings and monitoring and reviewing the configuration and activity. This is known as a shared responsibility model, which we'll cover in the next slide. When your organization is using cloud services or has a hybrid cloud environment, it's important to understand how you're using those services and how they integrate and interact with the rest of your environment. For instance, if your organization hosts all of your databases and computing power in your local data center, then you use a cloud provider for storage perhaps use S3 in AWS to disseminate reports to your customers. You now have the scope in the AWS Management Console, those S3 buckets holding that data, and your AWS Access Management into the audit. Auditors need to familiarise themselves with cloud technologies in order to appropriately audit them. Most IT auditors are probably familiar with more traditional infrastructure, such as on-premise servers and databases. But some cloud services are different enough that you might need to spend some more time understanding how they work and how they impact your audit before you can effectively work and assess the controls included in those services. And the last thing I wanted to bring up is that cloud computing is built on the idea of automation, where oftentimes a traditional audit sampling methodology might be overkill or unnecessary. For instance, when testing server configurations, you may not need to sample configurations of servers if an automatic deployment tool is used to automate the creation of those servers. This is the core idea behind DevOps, and it can greatly benefit auditors, which we'll get into in a bit. Cloud providers, as I mentioned, have this concept of a shared responsibility model. This diagram is actually one that Amazon provides on their website to explain this concept. These models are designed to outline who is responsible for enforcing controls at each level of the stack. You are still responsible for security in the cloud. And for the most part, this means that you still own and are responsible for your customer data. You're still responsible for securing any applications or SaaS products that you run in the cloud and configuring those correctly. And you're responsible for enforcing those controls and ensuring that they meet your own internal requirements. The cloud provider is responsible for the security of the cloud. So typically, for most vendors, this includes hardware maintenance and replacement and failover. It includes testing of the services and hardware. It's responsible for physical networks and physical security of that. And also the configuration of the platform if you're in a multi-tenant environment, so that multiple cloud customers can use their services and not impact one another. These sorts of models, while they apply to all cloud solutions and vendors, they will differ for each provider and each service that you use within the provider. It's not an easy concept to grasp, and the more you work with a particular cloud solution in your organization, you'll have a better understanding of which of these controls that you're responsible for and which ones you can rely on the vendor for. In the next few slides, we're going to go into the differences in a few different control areas and how they can impact your audit. These controls, the next couple of slides, have been taken from NIST's cybersecurity framework, and I just use them as examples. This particular control, for example, states that identities and credentials are issued, managed, verified, revoked, and audited for authorized devices, users, and processes. In both SaaS and PaaS environments, and IaaS environments for that matter, as I mentioned, physical access to the assets is often completely managed by the vendor. And indeed, most vendors keep the locations of their data centers a bit of a trade secret. When it comes to application access in a SaaS environment, so these are typically web-based platforms you'll use, as Christine alluded to before, so things like Workday or Intact or Dropbox. These compose a variety of risks, as they may not actually require users to be on a corporate network or using a corporate device to log into. You need to consider if you'll be controlling access to these services so that people aren't logging in from their personal devices, such as their phones or their computers at home. It's also important to control access to these services, as often they're not integrated with your on-premise directories. So things like deactivating access timely when an employee leaves or it's no longer required becomes a separate process. Some vendors you can integrate with your on-premise Active Directories, which, on one hand simplifies the administration, as now you still have a single access management process to audit, but it also adds technical complexity. You have to rely on the vendor a lot of times to enforce these controls. And a great example is just last month, Salesforce had an outage that impacted user permissions on its platform and either locked some users out or gave some users too much permission. This is something that you'll have to manage as part of your audit. In a PaaS and IaaS environment, many of these services come with a management plane or a management console that you can use to control these services. These management consoles often provide highly privileged access to the environment, so it's important to make sure they're in scope of your audit in the same way that a regular privileged user in a traditional environment is. Vendors often provide tools to manage and audit access to these different environments, so use them. AWS, for example, provides different tools where you can restrict access based on location, time of day, or if a user has used multi-factor authentication to log in. Similar controls exist in Azure. Again, across most cloud platforms will implement these controls as well. There are also a few different identity and access management standards that are used in cloud services, which makes integrating with either on-premise Active Directory deployments or your existing access management solutions reasonably easy. Logging and monitoring is arguably more important in cloud services than it is for internal services. Cloud service providers often give you the capabilities and tools to make this an efficient process, but you are still responsible for configuring and using these tools appropriately. In SaaS platforms, often they will give you a list of activity and logs from the platform and all the activity on there, but it must be enabled on the platform, and you have to have some way of ingesting that and reviewing those logs. Depending on the product, this can be either very easy, where they integrate with common log management solutions, or it can be difficult if the provider provides logs in a proprietary format where you can only view them through their web interface. Cloud service providers that offer PaaS and IaaS products often offer built-in logging and monitoring solutions that they may add an additional cost to your solution. Azure offers its log analytics platform, and AWS offers CloudTrail, and both provide tools to track and monitor user activity and API usage, and set alarms and take specific actions when events occur. Amazon, and indeed more cloud providers, often offer tools like GuardDuty, which continuously monitor for malicious and unauthorized behavior on your platform, using a combination of log analytics and machine learning. Most cloud providers, you can also set alerts to either alert your internal teams or to respond to events automatically to close any vulnerabilities. As with on-premise solutions, as I mentioned, the proper configuration and management are key to eliminating noise and ensuring timely responses. When it comes to change management in a SaaS environment, often you're at the mercy of your vendor to roll out changes to their service. You might have the option to release a specific version to your organization, but often a vendor will make a change and roll that out to all of their customers. You need plans in place to manage the changes so that they don't have any impact on your organization. For IaaS and PaaS solutions, again, you rely on the vendor to manage their internal changes to the underlying infrastructure. Anything that you've built on top of that infrastructure should fall within the bounds of your existing change management processes. If you adopt any cloud automation or orchestration tools and services, such as Chef, GitHub, Jenkins, or Ansible, you need to make sure that you include those tools in your audit, as if they're not configured correctly, they may inadvertently give people access to your production environments. And to ensure security of your cloud environment, authentication is another key component. In a SaaS product, again, vendors may be in control of the password requirements or how users authenticate. This can present a risk to you if those parameters aren't in line with what you deem as acceptable within your internal policies. Using multi-factor authentication is considered best practice, especially if you're not restricting sign-on based on the device or location of the user. And for PaaS and IaaS services, just like on-premise, you have the capability to manage your own authentication. Most providers allow for single sign-on to your existing Active Directory, and as I mentioned, this can lessen the management overhead, but it also adds another technical point of failure in your infrastructure. And this brings us to our third polling question. Has your organization performed a cloud risk assessment or audit? A, only an audit. B, only a risk assessment. C, both an audit and a risk assessment. Or D, neither.
Hi everyone, as a reminder, you must answer 3 of the 4 polling questions in order to receive CPE credit. You'll now get 1 minute to answer this question. I will now close the polling question and share the results.
Thanks, Katie. So 39% of people answered that they've performed both a cloud risk assessment and a cloud audit, and 34% noted that they've only performed a cloud risk assessment. This isn't surprising. Often when I go to help clients, performing a cloud risk assessment informs how they'll perform an audit on their cloud services. So the risk assessment really is the first step to designing an audit plan that suits your requirements. What I wanted to go into next was a lot of the material around cloud and its use in the security is often quite negative in that it's different and it's harder to control. What I wanted to go through now was how some of the impact of the different the automation capabilities of cloud and the different services that are offered can actually help you in ensuring the security and help you in auditing the cloud. Cloud services are built on this principle that you should be able to automate as much as possible. And this automation leads to more consistent, repeatable configurations. Things that you can automate and control and monitor, so things like logging and monitoring changes to your infrastructure. So particularly with IaaS providers, the providers give you the ability to monitor changes at a very granular level. This can allow close to real-time monitoring and alerting to abnormal changes. So if you have changes to specific servers, for example, made outside of a change window, this might raise an alert which can be investigated. The automated deployment of changes and updates is another key feature. So with the ability to arbitrarily provision new servers in the cloud or new databases or new infrastructure, you can essentially get the ability to pre-deploy infrastructure in a separate environment to validate and test. This is essentially the same model that a lot of applications use with a pre-production environment. But the benefit of the automation is that you can replicate the configuration exactly. Operational scanning and response. Cloud platforms give you the tools to perform ongoing audits or reviews of your configuration and alert on abnormalities. You can also actively respond to these findings either by remediating vulnerabilities or mitigating them completely until you can triage them. And detecting and responding to abnormal behavior. As I mentioned before, in near real time, you can detect abnormal behavior. But a lot of the capabilities of cloud allow you to automate a response to this. So a common example is used when someone opens a firewall rule that may be not in line with your policy. You can automatically remove that newly opened firewall rule and raise a security incident for it. This is all enabled by infrastructure as code. A core reason that infrastructure as code exists is to enable this automation. So in traditional infrastructure, when you deploy a change, often it requires a person to log into a server and make the change manually. This can either be by following a standard operating procedure, or they may even have a script or tool to help them make the change. This is hard to audit and monitor, and it's not repeatable, especially if you have to make the change across many servers, and it can be very hard to ensure that they all end up in the same state. The automation capabilities of cloud infrastructure allow configuration changes to be made through code. This means that the changes can be tested and reviewed before being made in production. Every change is completely repeatable and auditable, and the configuration code is the source of truth for how everything is currently configured. A lot of you will have seen a variation on this cycle, this DevOps cycle. This automation is often extended through development pipelines through developing the software using agile methodologies. Often it starts with the developer writing a piece of code that implements a piece of functionality for a user or fixes a bug. The code is then automatically unit tested to ensure, for example, that it didn't break any other components of the solution. The code is then reviewed by another developer. And once the code passes the code review, it can be deployed to a UAT or testing environment. And in this environment, a number of automated tests can run to check that there were no additional vulnerabilities introduced, that it didn't break any functionality for the user, that all the integration with existing systems goes well, and that any load balancing and capacity testing is successful. Once all these tests pass, the code can be confidently deployed to production. The benefit of this is that by deploying to production more often, changes become smaller and it reduces the risk of the change. In mature DevOps environments, so at large software companies, often this happens completely automatically, and they'll make hundreds or thousands of deployments per day. This next slide is just giving an overview of some common tools used for automation. I won't go through them in detail. GitHub is a version control platform now owned by Microsoft. It can be used for storage of code and configuration and accessed by multiple developers within your organization. Chef is an open source configuration management platform, so a tool that can be used to manage changes and roll out changes to your infrastructure. Jenkins is an open source development and testing platform. It can be used to automatically execute tests against your application to check that any new development didn't break existing functionality. And lots of people will have heard of Atlassian's Jira, which is an issue and bug tracking platform. This can be used to manage tasks and issues for developers and operational teams. From a control and audit and monitoring perspective, there are a few benefits of using a DevOps style environment. As I mentioned, all changes are completely repeatable. So you can look for the results of the automatic testing prior to deployment. There's no manual human intervention during deployments. So one, you know that all the deployments have gone as planned and are successful based on their testing. You can also investigate any changes that were made manually to the environment, because these are now abnormal changes, and investigate why they were made. You can increase the speed of deployments and changes. So as I mentioned before, the faster and easier you can make deployments, the more often you're likely to make a deployment, and so they become smaller because you're making more of them. This reduces your risk, both from a perspective of deploying the change, but it also means you can roll out patches and fixes a lot more quickly in, say, a 90-day patch window. You can do automated disaster recovery testing. Because the cloud lets you spin up arbitrary environments and services, you can redeploy your application in a completely separate environment from your existing infrastructure to test that the deployment works. You can automate code reviews and vulnerability scans that happen every time you deploy rather than quarterly or yearly. And as I mentioned before, you can monitor and log every change in your environment to alert for changes made to high-risk areas, such as administrator access. The last topic I wanted to cover quickly was around data governance. So this isn't specific to cloud, and everyone should have some level of data governance strategy, but it should take into consideration how you use cloud services. The data classification scale should help you guide that you only allow data with the appropriate classifications to certain providers, certain geographic regions, or even out of your own data centers. The data usage portion of your data governance strategy should determine who can access that data. Is it appropriate to have this data stored with a third party or even a cloud provider's third party? Your data encryption portions should help you understand how you're going to manage encryption within your cloud service provider, who manages the encryption keys for the data, and can the cloud service provider provide the services they need if they don't have access to the data. A common use case for this is if you're doing analytics or indexing of data in a cloud provider, they will often need access to the unencrypted data to need to do this. How do you manage and detect data from being exfiltrated from your organization? So are there preventative controls or detective controls you can activate to understand if someone is taking your data from the cloud provider and not their own infrastructure? And lastly, data retention. Based on the type of data, how long does it need to be retained, and how can you ensure that your cloud provider isn't storing this data after you've removed it from the platform? The Cloud Access Security Broker is a software appliance that can be positioned between your infrastructure and your cloud service providers. These often give visibility and identification of the shadow IT cloud services that we mentioned previously. So employees using products like Dropbox or Gmail within your organization, you may not have visibility into. It also offers a central control panel across different cloud services that you can use to enforce and control access and log and monitor the different services. And that brings us to our final polling question for today, which is, which cloud platforms does your organization use? And these are just a few of the very common ones. So A, Amazon Web Services, B, Microsoft Azure, C, Google Cloud, D, some of the above, or E, none of the above.
Thanks, Chris. As a reminder, you must answer 3 of the 4 polling questions in order to receive CPE credits. You will have 1 minute to answer this question. We'll be closing this polling question and sharing the results.
Thanks very much, Katie. So about what I expected. So Amazon and Microsoft are by far the 2 largest and most well-known cloud providers. Google Cloud specializes a little bit more in a lot of analytics and machine learning type capabilities, and they do offer some of the same services or similar services to AWS and Microsoft. And it looks like the majority of people use at least some of these services as well. Just before we close, I wanted to provide a bit of an insight into the different toolkits and methodologies that I've personally found helpful as I work with clients to help them evaluate their use of cloud services and help them ensure that they don't have any control gaps and that they have all the right capabilities in place to monitor their use of it. I won't go through each of these individually, but needless to say, they're a combination of standards from organizations like NIST and ISO, but also Cloud Security Alliance and ISACA offer some really good toolkits that you can use and adapt to your own organization. So to recap, today we've gone over basically what is cloud. If a cloud service typically features the characteristics of being internet-based, self-service, scalable, resource pooling, on-demand resources, and granular pricing. Cloud strategy is important because the use of cloud-based services continues to grow worldwide, and many organizations have experienced breaches due to lack of these controls. What are the next steps for your organizations? You need to work with management to understand and evaluate cloud strategies and governance within your organization. You need to understand your current vendor management practices, including the suitability of those to cloud. You need to understand the shared responsibility model and its impact on your controls. And you need to be able to stay current on cloud technologies and how they're being used and how they impact your organization.
Hey, thanks, Chris and Christine. Just kind of looking at some of the questions. We got a handful in. We'll see how many we can address before we wrap things up here. The first question, I think, Chris, might be a good one for you, is this AWS shared responsibilities for IaaS or PaaS?
So that's a very good question. The diagram that we showed that Amazon provided was that split of responsibilities between customer and AWS. Ostensibly, it applies to both their IaaS and PaaS service offerings. However, what you find is with each individual service offering, the split between that will differ. So, for example, they provide a platform as a service database called their relational database service. That includes basically everything they had in their lower portion of the cloud: the compute, the storage, the database, the network. It includes a lot of the server-side encryption, which in that diagram is in the customer level, and it includes a lot of the networking traffic protection. They then give you controls to implement encryption for your data, to do monitoring of how the data is being used and access management to that data, and then how you allow people from externally, either from the internet or your own organization, to access it. So I do want to stress that is just a guide, that model, and it does differ based on the individual service that you're using. And even, a lot of the controls they give you are configured with what Amazon like to think are best practice defaults or sensible defaults. So for some of them, if you don't have a particular need to change it, you can rely on Amazon to have implemented it at the, a good level of the service being usable, but also having a secure configuration. When in doubt, it's really good to either ask your cloud provider or ask your internal IT teams or vendor teams who are managing a specific application about that.
Thank you. Another good question that's probably relevant, for all of us to understand, and again, kind of goes back to your section, I think, Christine, around SOC reports. The question is, what should management do if the SOC report we receive has an adverse opinion? Are there compensating or mitigating actions that we should be taking?
Definitely. If you aren't already a customer of the cloud service provider, think twice before going there. However, if you're already a customer, definitely work with a cloud service provider to really understand the impact of the adverse opinion, to best know how and if it affects you. It pretty much means it's a weak control environment, but it doesn't necessarily mean that something bad happened. It is just a good chance that either it could or it did happen. So if you have a right to audit clause, definitely take advantage of that. Determine if maybe your SLAs give you sort of a right to dig in more with the cloud service provider. I actually had a client a few years back who was in the middle of migrating half of their environment to this cloud provider before they even asked for the SOC. And when they got it, they realized it was adverse. The cloud service provider was really pretty good at responding to all the questions and letting them get a lot more information. I think it behooves most cloud service providers to really get into detail about what the actual finding and the details of the findings are, because in the SOC report, it's just sort of a few sentences about what happened, but you don't really get into the details. If the SOC is a SOC 1, which means it's for financial reporting, your external auditors may have to perform more substantive procedures to get comfort for the audit. And then maybe that will also help them gain comfort if it's a SOC audit as well, to put it into more perspective. But I guess the bottom line here is don't right away go to this cloud service provider if you're not already a customer. And then if you are a customer, I think the the cloud provider definitely owes you a lot more information. So keep utilizing what's in your clauses to get that information as best as possible. But I have found that these cloud service providers have been helpful in these types of situations. So there's just a lot of follow-up that needs to be done.
Thanks, Christine. I will just add to that as well. It's probably important to, when you have a SOC report with an adverse finding, actually understand what the impact of that is, particularly if you're with a cloud service provider, one of the large ones that offer tens or hundreds of different services. There might be an adverse finding that's in a service that you don't use, or that it just doesn't impact the way that you're using that service. I know it sounds common sense, but I've seen it in at least one situation before where someone has looked at the headline of the SOC report that said the vendor name and adverse finding and discounted it without actually understanding what it was. So, yeah, to that point, I think it's very important just to sort of work through what the actual impact of that finding is, and if you can mitigate it or if it's a deal breaker for you.
Thank you. I think it brings us to a great kind of closing point. Christine and Chris can't thank you enough for kind of sharing all of this thought leadership. We could probably talk all day about it, but have an hour. So I just want to thank everyone on the line for attending today. We appreciated having you here. Everyone can expect an email within the next day or so with a recording of this webinar as well as the presentation slides. And then also following that, a certificate of completion will also be emailed out within about a week. You should see that. So again, thank you very much for joining us. We look forward to connecting again, and have a fantastic day.